So this video is going to go into something called polyatomic ions. Really the main thing to know is there are times when we can have groups of nonmetals that are bonded together covalently, but they still form a charge. These are called polyatomic ions. Really, like let's say we're told there's a molecule called SO4. It has a name, sulfate. Really the big thing that we just need to know is what charge does that polyatomic ion have. And we're going to have a sheet that's going to help us explain it. The internet server is going to help us with that. Big thing though, charge is -2. We find that out. I know it's a little hard to read. It'll get easier the lower I work. Figuring out ionic formulas for these polyatomic ions, it works just the same as the binary ionic compounds, right? So let's say our SO4 there, let's say that it's going to bond with aluminum. Right. So aluminum, it's in column 3 of the periodic table, 3 outer shell electrons. Two questions are, is it closer to 0, closer to 8? 3 is closer to 0, so we're going to give away those 3 electrons. We're left with more positive protons, 3 more positive protons than we do negative electrons. So our charge is +3. Right, so just as we did with the binary ionic compounds, we wrote the charges. The next step is to crisscross them. Write the charges crisscross. So we wrote the charges up there. Now we just need to crisscross them. Remember, when you crisscross, you lose the sign. Now we already have a number here. So I would say before we crisscross, let's take our polyatomic ion here, and let's put parentheses around it. Because I'm not changing anything in the parentheses. I can put numbers outside the parentheses, but I can't change what's in there. My SO4 will always be 1 sulfur, 4 oxygens. But the charge on one of these molecules is -2. So now when I crisscross, my 3 is going to go outside the parentheses. It's still subscript, it's still kind of below it. And my 2 here is going to go with the aluminum. So I'm going to have Al2, and then in parentheses, SO4. I'm going to restate that. We don't change anything in the parentheses. So that stays SO4, but we're going to have 3 SO4. So we're going to put a 3 outside the parentheses. So just for figuring out the formula, that's all we have to do. Put our polyatomic ion in parentheses, crisscross them. So for instance, let's say that we're working with phosphate. Phosphate is PO4 with a charge of -3. So let's go ahead and put that in parentheses. This time, let's say we're talking about sodium phosphate. So sodium, Na, it's in column 1, 1 outer shell electron, gives it away, forms a charge of +1. So I already put my polyatomic ion in parentheses, and I'm just going to crisscross and go outside the parentheses with it. So that 1 goes out there, that 3 comes over here. So I end up with Na3 PO4. Now, since there's no number outside the PO4, I don't need to have the parentheses there. It could just be Na3PO4. You don't need the parentheses, but if you want to leave them, I'm alright with that. Just knowing a textbook in college, you're not going to put those parentheses there. But for now, I think it's easier to keep them there. It's more useful to remember we don't touch what's inside of here. That stays the same. So really, polyatomic ions, they're no different than just straight up nonmetals. Chlorine, oxygen, nitrogen. If they're going to give you the charge on these, you won't have to figure those out right now. So they give you the charge, you just write them up, crisscross them. We're going to be working with one positive polyatomic ion, that's ammonium, NH4+. And just remember, with our formulas, the metals go on the left, or I should say, the positive ion goes on the left, the negative ion goes on the right. And it'll be true when we get to naming as well, which we'll start naming polyatomic ions tomorrow. It's really easy, so don't worry about it too much.